All right, folks, here's a video on related rates from yesterday, week 14, Tuesday, number 3578. Just make sure I got those right numbers. Yep, so let's start with number 3, okay? So we're gonna set up, here's some givens. Basically, we got sand leaking out of a cone, okay? So sand, so we're going to be using volume of a cone, which is 1/3 pi r squared h, okay? And what rate is the height of the sand changing? So we're going to want everything in terms of h, okay? So I'm going to substitute, I'm going to rewrite r in terms of h's, and then end up taking the derivative, plug in, and then isolate for dh dt, okay? So, so here we go. The R here is, okay, the R here is 4, okay, and here's the R, okay? So R over H is equal to 8 over 12, okay? So, excuse me, is equal to 4 over 12. So I'm going to write this. That's basically what they wrote here, but I'm going to do it my way. R over H is equal to 4 over 12, okay? And, okay, you can cross multiply or just multiply both sides by H. And if you multiply both sides by H, you basically get 4 over 12H, or R equals to 4 over 12H, which is the same as R equals to 1/3 H. So that's what this is here, okay? So we're going to substitute in 1/3 H for R, and that's what happened here, okay? And then we're going to simplify it, okay? H squared times H is H cubed. 1/3 squared is 1/9 times 1/3 is 1 over 27, and the pi carries over. Now I take the derivative of this, okay? The derivative of this, you're going to get, you're basically going to get a v prime and an h prime at the very end, and then the 3 moves over to the left because of a power rule. 3 over 27 is the same thing as 1 over 9, okay? And then h cubed becomes h squared, again through the power rule. Pi carries down. So basically this is your derivative here, okay? And now we're going to plug in, okay? We're going to plug in 6. Where's the 6 for H? Where is the 6? Width equals to 2R. Oh, sorry, I'm being a dummy. So if R is, if R 6, oh, yeah, sorry, I don't know why I completely brain farted there. If R is, so if, oh, so this is going to be 4. Okay, that's going to be 4, that's given, and R, that means R right here is 2, okay, and so if R is 2, what is H? So if R is 2, H must be 6. So I plug in 6 into H, okay, over here, and I get that, okay, and I plug in -2 in for dv dt, okay, because it's leaking out, so it's negative, and you solve backwards for dh dt. Okay, let's go to number 5. Okay, number 5, here we go. We have some, so we have this diagram over here, okay, and it's asking for how fast is the water level rising, okay? So let's just look at this. So basically, let's look at this volume over here. And the way I conceptualize it is I take one area of the triangle, which is 1/2 base times height, or 1/2 length times width. That's a two-dimensional area of this triangle face right here. And we stack it from front to back according to the depth, or they call it the H. This 15 feet is the H, the capital H. So you can think of it as, I like to think of it as two-dimensional coasters that you put on a table to prevent a drink from slipping. So this is a triangular coaster that you put on a table that's two-dimensional, and then we stack 15 of them to eventually get the volume of this solid right here. Okay? So the formula we're going to be using is the volume of this triangular prism, which is 1/2 base times height, or length times width, stacked H times. H is the 15. Okay? So let's just look at one of these two-dimensional cross sections. We got 3 and 4, which is given for base and height, or in this case, they call it length times width. Okay? So this right here is that. Okay? And then the blue triangle, which represents the water. Okay? This right here is right here. Okay? And I call this length and width. And so the ratio of L to W is 4:3. And when you isolate L, you get 4/3 W. Okay? So again, they're asking for the change in the height of the water. I wish they use little h, they use little w. So they're asking for change in W over change in T. Okay? So that's why we want everything in terms of W here, of little w. Okay? Again, it's asking for the change in height over change in time, but instead of using little h, they use little w. So we want the change in W over change in time, so we want everything in terms of W. Okay? So I substitute this in for L, and I get that. Okay? I simplify, okay, this whole thing, and I get that. Okay? 15 times 4 is 60 divided by 3 times 2, which is 6. 60 divided by 6 is 10. Okay? And so I get this, and I take the derivative of both sides, and I'm left with, it creates a V prime and a W prime. Okay? And how are we doing on the stuff right now? Guys, are you doing okay? All right. So now I substitute, sorry, I was talking to the class to make sure they're doing okay. Change in volume over change in time is going to be change in volume over change in time. Okay, is going to be 2.5. All right. Your W, okay, that we're going to plug in 2 feet deep right there. Okay. And then this kind of tripped me out for like 3 seconds. So they divide both sides by 20 times 2. Okay. But what's up with this 5 and 2? It's because 5 divided by 2 is 2.5. So they just rewrote this decimal as a fraction. Okay. And then basically we accomplish our goal of isolating dW over dt, and it's 1 over 16 when you simplify this. Okay. Let's do 7 last. Let's go to 8. Okay. Now 8, okay, I like to think of this as, when you read this, I like to think of this as your position function. Okay. And it's asking for your velocity function. Okay, but let's see if I can talk about in the context of this problem. So this is miles per gallon. Okay. And we want the rate at which the MPG is changing. Okay. So the rate at something changing means you've got to take the derivative of this. Okay. So here's your original function. When you take the derivative, the constant is going to stay. Okay. And then the e to the power whatever is chain rule, derivative of outside leave inside, which is this. Okay. And then you got to take the derivative of the inside itself, which is this. Okay. And then because s is a function of t, there's a s prime. Okay. So this is your derivative. So basically, this becomes this after you take the derivative. Okay, now we just plug in for s. Okay, 50 for the s's, and that's what happened here. Okay, ds dt is the 20, and then you just plug this in your calculator and you're done. Okay, now, and you should get 4.299. Now, if you want to do it an alternate way, watch this. I'm going to take the derivative of this using the calculator. Okay, so I'm going to go y equals to, if it wants to turn on, let's restart it. Browse. Let's restart it here. Okay, y equals to 6 e to the power of x over 20, okay, minus x squared over 2400, okay, all right, and I am going to quit that and then go to mode, whoops, my bad, go to math, okay, go to math, go to option 8, and go ddx, and here I'm going to recall the y sub 1 function that I inputted earlier, okay, and I want to evaluate this at x equals to 50, okay, because I'm plugging in 50 for the s's, in this case x, okay. Let's see if I did that right. I get, so, and then don't forget I have to multiply it by this 20, okay. So that basically gives you, this, okay, but then I have to multiply it by the 20, okay. So once I multiply by the 20, I should be good to go. Boom, boom, and I get 4.29. Okay, here's number 8, or excuse me, number 7. Okay, number 7 is a longer problem, but it's the same idea. Okay, same exact idea. So, let's see. Boom. Now, how fast is the level in the pot rising when the coffee is 5 feet deep? Okay, so we have a cylinder. So for part A, we're only focused on this right here. Okay, that's the formula of a cylinder, which is pi r squared stacked h times, or they call this y. Okay, so r is always going to be 3, which is half of this 6, so they just plug that in right away. Okay, and then when you take the derivative of this, you're going to get this. Remember, v becomes v prime, y becomes y prime. And now we just plug in what we have. Okay, dv dt. Whoops. Whoops, I don't know what happened there. Here we go. dv dt is 10. Okay, so that gets plugged in, and we isolate for dy dt, and we get 10 over 9 pi. Okay, and that's part A. Here we go. Part B, it refers to the cone. Okay? All right, so we're going to use 1/3 pi r cubed h. Okay? So, I am just going to jump straight to here in the answer key. All right? And it's asking for dh dt, because cone, how fast is the cone falling? That's vertical, so that means dh over dt. So I want to rewrite this in terms of h. Okay, so here we go. This is 3. Okay, this is 3. Okay, because the diameter is 6, and this is 6. Okay, that's r. and that's h. So 3 over 6, so r to h is 3 to 6. Okay, let's see if they wrote that down over here. Okay, let's see if they wrote that down. Yep, r over h is 3 to 6, and when you isolate for r, or when you write r in terms of h, you get h over 2, and then we plug that in. So we plug in h over 2 in for r. So this gets plugged in for r right there, and we just simplify it and get that right there. Now we take the derivative of both sides, okay, and we end up getting this with a h prime and a v prime, okay, and then we just plug in, and then now we just plug in dv over dt is going to be negative 10 because it's dripping, it's not positive 10, it's negative 10 because it's dripping out of the cone, okay. Let me get rid of my highlights here. It's dripping out of the cone. All right. And then we got a radius of 5. An h of 5. Oh, copying the cone is 5 feet deep, so that's where it came from. Yep. Okay. And then basically I just do some algebra and isolate for dh dt. Okay. And they say this is, okay, so this is for me, for my purposes, this is good as your final answer. But they changed this to positive later on, okay? Because falling already implies negative, okay? Falling implies negative. All right, and then so it's falling, which is negative, which implies negative 8 over 5 pi. So what they're basically, this whole thing in simple terms means you don't need to write the negative in the final answer because falling already implies negative. Okay, just a matter of semantics or just wording. Okay, and that is 3, 5, 7, 8 from yesterday. Thanks for tuning in, folks.